narrow beam of proton, each having energy of 4.1 mega electron volt, is approaching a sheet of lead. Instead of gold foil, it's going to approach a sheet of lead. And the atomic number of Z is given to be 82. So when the proton is approaching, they've given the kinetic energy, they ask you for velocity. So then half mv square is equal to 4.1. Mega means 10 to the power 6. Electron volt means 1.6 into 10 to the power minus 19. So now we can take the 2 to the other side and divide it by m, which is the mass of the proton, which is 1.6 into 10 to the power minus 27. Okay, 1.67 into 10 to the power minus 27. Okay, whatever it is. And then you find the square root of this. You'll immediately get the value of velocity, which turns out to be 2.8 into 10 to the power 7 meter per second. In fact, in the exam, if you want to, you can calculate the 1.6, makes this 4.1 as 4. And this is 2 root 2. Directly you'll get 2 root 2 and you can resolve the rest of the powers. That becomes easier for you to solve it, but this is the way to solve. Next question is the first subdivision, which has been answered. Second subdivision, distance of closest approach. To find the formula for distance of closest approach, you know, half mv square has to be equated to k is e square by r, and this is r naught is equal to k is e square by, this is kinetic energy, which itself has been given in the question. Just plug in this, but make sure it is in joules, because you're finding the distance in meters. So 9 into 10 to the power 9 into z of the lead is 82 into 1.6 into 10 to the power minus 19 the whole square by the kinetic energy 4.1 into 10 to the power 6 into 1.6 into 10 to the power minus 19. So this and the whole power get cancelled. And
minus 1341.
No, 1.6 to the power minus 19. He is calculated with this 6.
Okay.
We will not do that. Okay, just do this calculation, get the distance of closest approach, whose value will be 28.8 Fermi. Fermi means 10 to the power minus 15. Okay, you are supposed to get an answer like this, which you can write it as Fermi. Okay, meters. So that's about this. Let's go to next question. Example 2. The example 2, the question is, in a giga maths and experiment, what is the distance of closest approach of nucleus of a 7.7 mega electron alpha particle? This question is only about alpha particle before it comes to the rest and reverses direction. Distance of closest approach formula for that will be k into 2ze square by kinetic energy. Because they have already given in this question the energy of the alpha particle, 7.7 mega electron volt of alpha particle, which can be plugged in here, 7.7 mega electron volt. Okay, so that's about it. And the numerator has got 9 into 10 to the power 9 into 2 into what is that? It's only gold foil, right? What is the atomic number of gold foil? Is 79. Okay, into e square is 1.6 into 10 to the power minus 19 the whole square. And this you calculate, you get the distance of closest approach in this case, which turns out to be 30 Fermi. Just do the calculation, check out if you're getting this. That's a 30 into 10 to the power minus 15 meter. Okay, let's go to example 3. The beam of alpha particle, so again alpha particle with a velocity is given to be 2.1 into 10 to the power 7 meter per second, is scattered by a gold foil of atomic number 79. Find the distance of the closest approach of alpha particle, the value of the charge by mass. They've given charge by mass of the alpha particle. So you don't have to necessarily calculate the charge by mass. It's not the usual charge by mass of an electron. This is charge by mass of alpha particle. Okay, but normally how do you find the charge by mass? Is 1.6 into 10 to the power minus 19. But here is alpha particle's charge. It's not one electron's charge. An alpha particle always carries a charge of 2, helium. So it's 2 into. And mass of helium. Mass of the helium is 4.
4, okay.
Helium 2, 4.
Okay, yes.
Okay, if they don't give, you have to take it as 4. Or 4 times the mass of hydrogen. In fact, you should take it like that. So that mass of hydrogen, 1.6 into 10 to the power minus 27. This is what is charge by mass in this case, not the usual charge by mass of an electron carrier. So then when you calculate this 1.6 and 1.6, this and this get cancelled, you get it 0.5. This goes up, it's 10 to the power 27. 27 minus 19, there is an 8 here. So it's 10 to the power 8 is what is this. What have they given charge by mass ratio to me? is 4 into, that's approximately equal to 5 into 10 to the power 7. Can you see?
Yes.
If I write it as 5, which means I'm multiplying by
Okay,
7, so I'm
10
also multiplying by 10, dividing by 10. So it becomes 10 to the power 7, which is correct. So please understand that what is, they might ask you what is the charge by mass ratio of an alpha particle. That can also be a board question. You should understand the charge is 2e and the mass is 4 times the mass of the proton. Is 2 times the charge of a proton and 4 times the mass of the proton, because it's helium 2 into 4, which when compared with hydrogen H11, you know that the charge is 2 times that of hydrogen, that's a proton, and 4 times that of the proton. And so mass of the proton's value will be given in the question paper, otherwise it's 1.6 10 to the power minus 27. So therefore you get 5 into 10 to the power 7 or 4.8, which has been given. The charge by mass or coulomb per kg has been given. So that's been given, but I'm just explaining to you. So then it's not a simple, this is 2e by 4 mp. It's not e by m. You understand? So then they have given that also. Find the distance of closest approach. The formula for distance approach for an alpha particle with a gold foil, is it? Yeah. Is this same formula? K2 is at E square by half kinetic energy. Is the kinetic energy been given? No. They've given velocity. So write it as half m v square and plug in this value of v in here. Okay, you know the charge by mass. Okay, but this is it's not 2, you don't need this 2e kadayad. What take the 2e, right? Split it up, k into 2e into e by z by half into m into 2.1 into 10 to the power 7, like this. And you know 2e by 4. Here m is not m. M actually will become 4m.
Okay.
And this 2e, this itself is 5 into 10 to the power. Very, very clearly, when you write half mv square, m is not m. M is 4 times the mass of the proton. And charge, one of the charge we saying Ze is fine. Ze is fine. But the other E is alpha particle, then it's 2e. Is it alpha particle?
Yes.
Yeah, so you will also have an additional 2 here. So then Ze by a 4m. But I've written 2e.
2e.
Why 2e? Because it's an alpha particle.
Alpha
okay.
particle 2.
So you have a, let me rewrite this and become clear. It's k into, the 2e is for the alpha particle and the Ze is for the gold foil. Correct?
Yes.
By a half m is of the mass of the alpha particle, which is 4 times the mass of the proton, into v square. V can be plugged in. But here you should see what has been given is the charge by mass ratio of alpha particle. Alpha particle's charge is only this 2e and the mass is 4 times. This one has been given. So it's 9 into 10 to the power 9, which is k, into 5 into 10 to the power 7, into Ze is not being given. What is Z? It's given in the question that Z is 79, into E is 1.6 to the power minus 19, by a half which is there, which will go as 2 up, and a V square which is 2.1 into 10 to the power 7, the whole square. Substitute all this value, you should get the answer. Are you clear?
Yes, sir. 2.5.
They have given this to be 4.8 into 10 to the power 7. So you can substitute 4.8. So that should give you the answer. The answer has got to be 2.5 into 10 to the power minus 14 meter. Check out. The whole tactics is to identify what is charge by mass. It is not E by M. Because for an alpha particle it becomes 2E by 4 MP.
Okay.
So you have to consolidate the formula in accordance to that. Very, very important question. So let's go to next question. Example 4. An alpha particle, after passing through the potential difference, so V has been given to be 2 into 10 to the power 6 volts, falls on a silver foil. Here for a change it's silver foil, correct? And the atomic number of silver is given to be 47. Calculate the kinetic energy of the alpha particle at the time of falling on the foil. So the kinetic energy, half mv square, is equal to, they have given the voltage. Whenever they give you a voltage, you know V is equal to W by Q.
Yeah.
So W is equal to V into Q. So this is nothing but the total energy. The energy is always potential into charge. So just take the potential, what is 2 into, so they're asking for what is the kinetic energy of the alpha particle when it hits the foil. Energy is always equal to V into Q, which is 2 into 10 to the power 6, into what is the charge? The charge of this alpha particle. Is it alpha particle which is coming in? And what is the charge of alpha particle? It's 2e. Correct?
Yes.
So then it's 2 into 10 to the power 6 into 2 into 1.6 into 10 to the power minus 19 should give me the energy. So it's 2 into 2. Can you see? 2 into, where is 1.6 and where is 2 into 10 to the power 6 voltage?
2 into 10 power 6.
How many 10 to the power 6 I have? 1 10 to the power 6 and 1 10 to the power minus 19. Correct?
Correct.
So then the answer for this is multiplied as 3.2, 6.4 into 10 to the power minus 13. So that's the energy with which it's going to hit the gold foil, correct? So we found no need to use half mv square. When the potential is known, the energy is V into Q, and Q is of the incident alpha particle. Okay, charge of the alpha particle, which is 2e. Are you clear? So energy which we've got in joules. Now, next is what are they asking? Calculate the kinetic energy. The kinetic energy of the alpha particle at a distance 5 into 10 to the power minus 14 meter from the nucleus. So you have a nucleus. When the alpha particle is at a distance of 5 into 10 to the power minus 14 meter from the nucleus, find the kinetic energy. You know, at this point you will have kinetic energy plus potential energy, which will be equal to, at the closest distance when it came, it will have an energy, right, which is this energy.
Okay.
Yeah, which is 6.4 into 10 to the power minus 13. At this point you only have potential energy. No kinetic energy. To be frankly speaking, closest is potential energy, farthest is kinetic energy, and therefore what you have is only potential energy. The kinetic energy here is 0. So you know this kinetic energy is what they are asking you to find at a distance. Potential energy's formula is K Z E square. We have to fill in 2Z E square. K2 Z E square by R, which is R naught, which is 5 into 10 to the power minus 14 at this distance.
Okay.
Is equal to 6.4 into 10 to the power minus 13. So you can take it to the other side. You have to calculate and take it to the other side. So K is 9 into 10 to the power 9 into 2 into Z. Here is silver, right? 47. 47 into 1.6 into 10 to the power minus 19, the whole square. Correct?
Yes.
Divided by, what else you have? You have a 5 into 10 to the power minus 14. Calculate this value and subtract it to get the kinetic energy of this. Are you clear? The value has got to be
4.3
4.3 into 10 to the power
minus 13.
No. After subtraction, sorry. This value, this calculated value, this is, can you see 9 into 10 to the power 9 into 47 into 2 is what is 9 to 24. 1.6 10 to the power minus 19 the whole square by 5. With this value, it turns out to be 4.3 into 10 to the power minus 13. You make sure that the powers are the same so that you can subtract.
Okay.
So you can subtract and you can get your answer, which is 2.1 into 10 to the power minus 13 joules. Are you clear?
Yes.
So that will give you the kinetic. This is by conservation of energy. Okay, so then next question is the fifth question. The fifth question in SL Aurora, the number of particles scattered at 60 degree. This is a concept which we never learned, but let's learn it now. I told you that a number of particles of scattering and theta are inversely proportional. N is inversely proportional to theta. They are being very specific. They are saying it's proportional to sine to the power 4 theta by 2. If you can memorize this, you can include this in the theory part.
Okay.
So it's 1 by sine to the power 4 theta by 2. So what are they given? An angle is 60 degree. So theta becomes 60 by 2, which is 30 degree. So n is inversely proportional to sine to the power 430. What is sine 30? Sine 30 is 1 by 2. 2 to 4, 4 to 8 into 16. It becomes 1 by 16. Therefore n becomes 1 by 16. Okay, keep it like that. Keep it like that. This is my n. So you understood that. Let's read the question. Number of alpha particles scattered at 60 degree is 100 per minute. There are 100 particles which are scattered per minute. Okay. Calculate the number of particles per minute scattered at an angle of 90 degree. So they have given the number of particles scattered at 60 degree. They are asking for number of particles scattering at 90 degree. So what you do, you just do number of particles scattered at 90 degree divided by number of particles scattered at 60 degree, because it's a proportionality.
Okay.
With k by sin to the power 4 90 by 2
Okay.
by k by sin to the power 4 60 by 2. The k and k get cancelled. This goes up. Sin to the power 430 by sin to the power 445. So what is sin to the power? We just found it to be 1 by 2 sin 30. So it becomes 1 by 16. What is sin 45 is 1 by root 2. So it's 1 by 4. And 4 and 4 get 16 get cancelled. So answer is 1 by 4. You know the scattered number of particles for 60 degrees is 100. So number of particles scattered at 90 degrees 100 by 4. Therefore you get 25 particles scattered per minute. Because whole sum was based on minute, I have not changed it into seconds. Are you clear?
Okay.
So let's go to sixth sum. Calculate the impact parameter of an energy given. It's 5 mega electron volt particle. They didn't give it's alpha particle or proton.
Okay.
They just said particle. So there's no 2e. Okay. Scattered at an angle of 90 degree when it approaches a gold nucleus. So it's approaching a gold nucleus. You should know atomic number of gold is 79. So the impact parameters formula is the same as R naught, distance of closest approach, including cot theta by 2.
Okay.
Okay, but there it was an alpha particle, so we used to write k2 is at e square. But here it's only an ordinary particle, so k is at e square by R naught. No, by kinetic energy, half m v square into cot theta by 2 is the formula for impact parameter. So substitute all these values that they've given. The energy is 5 mega electron volt.
Okay.
5 into 10 to the power 6 into 1.6 into the power minus 90. And what else is given? Z of the gold foil is 79. You know all the value. They have given the angle 90 degrees. So it will become cot 45. Tan 45 is 1. Cot 45 is also 1. Substitute all this value. You get the impact parameter 2.27 into 10 to the power minus 14 meter. That's all. Okay. Are you clear?
Yes,
so let's go to next question. Next example. Yeah. So let's take the next example. It's the example 7. Evaluate Rydberg constant. I told you what is Rydberg constant. It will come in nu bar, which is equal to 1 by lambda, which is equal to minus r into 1 by n I square minus 1 by n final square. Unlike the video where I have written n1 and n2, which is this is Reynolds number whose Rydberg constant. Sorry, again same mistake. Rydberg constant whose value is 1.09 into 10 to the power 7 per meter. They're asking us to calculate this. They didn't take it as a constant. In order to calculate that, by putting the values of the fundamental constants. But what was there in the place of r? To find r, you need to know what was there in the place of r. Let's quickly find out. Let's write energy. Energy's formula is k is it e square by 2r, where we'll write r as n square h square by 4 pi square k. So k is it e square by 2 into n square h square 4 pi square m k is it e square. This and this gets cancelled. So you know what is the formula other than n and other than z. So what is the rest of the things that's there? Z square can be taken out. So you have k to the power 2 e to the power 4 2 into pi square into m by n square can be taken out and h square. And this is what we are terming it as. It is minus k is the d square by 2r. Sorry. So there will be a minus sign. On this is the value which gets you your Rydberg constant 1.09, considering that z is equal to 1. Remember? And so we'll group it and we'll write as n I square minus upper limit minus lower limit when you integrate. It will be coming from jumping from n initial to n final. So when you do upper limit minus lower limit, it's becoming actually it's n I square initial square by n final square. Correct?
Square, yes.
This is the formula we learned. Correct?
Yes.
So yeah, leave it like that. Okay, just leave it like that. So this is the value which we used to write it as a Reynolds number, Rydberg constant, again and again the same issue. So let's calculate this. What is 9 into 10 to the power 9 the whole square into 1.6 into 10 to the power minus 19 the whole to the power 4 into 2 into 3.14 the whole square into m. What is this m? This m we have taken it from r. And for R, it was all about Bohr's postulate. An electron was so it's about R. The M is about the mass of the electron.
Hydrogen, no?
Electron revolving. What is Bohr postulate? An electron revolving around the nucleus. Oh, okay. But this is about the radius and all that, which is calculated based on the mass of the electron, not on the mass of the hydrogen atom. So now we're not talking here about the entire mass, because we're finding the radius. In fact, we did it mv square by r. What is M stands for? Mass of the electron, centripetal force. Remember, so that is that M, and therefore no doubts. M stands for the mass of the electron, which is 9.1 into 10 to the power minus 37 by h square, which is 6.6 into 10 to the power minus 34 the whole square. Just calculate this value. You should get this value. Okay. You have to get this. Has he plugged in this anywhere to find where is the sum? Yeah. Has he written this? 2 is there. Tell me what all is there? 9 into 10 to the power 9 the whole square is there. 1.6 into 10 to the power minus 90 the whole to the power 4 is there. 2 is there. You don't. 9.1 is there. Into 10 to the power minus 31 is there. 3.14. They have done pi square. Pi square itself is 9.87. That's what they have written here. By 6.6 to the power minus 34 the whole square. And what is this that they have? Yeah, okay, I missed something. Okay, in this, remember this you have to write h into E is equal to h mu. Instead of mu, you should write C by lambda. That's when you get 1 by lambda, where h comes here as h cube. There will be additionally one more C. So you'll have h cube into C. So you have to write h cube, not h. And into C, which is 1.6, no, C is 3 into 10 to the power 8. So get this value of what you substituted 1 by lambda, you have to write I forgot this, h mu is equal to C by lambda, and then group it. So this is how you find the Rydberg constant. Let's go to next question. Question number 8. Calculate the value of fine structure constant. What is the meaning of fine structure constant? They are calling fine structure constant as alpha, which is 2 pi k e square by ch. How did they get that? So a fine structure constant is this, which we get it as 1 by 137. So take the velocities formula, multiply and divide it by c, group it in accordance and assume z is equal to 0. This value you calculate, you get 1 by 137, and this is what is called fine structure constant, which is the derivation of velocity. Okay, so just remember that. So they might ask you to just write the derivation of fine structure constant. You should be able to do it. So let's go to example 9. What is the angular momentum of an electron in the third orbit? Angular momentum, according to Bohr's postulate, is nh by 2 pi. So when third orbit means n is equal to 3. So L is equal to 3h by 2 pi, which is 3 into 6.6 into 10 to the power minus 34 by 2 into 3.14. That's all. Just calculate it, and the answer will be 3.15 into 10 to the power minus 34 joule second. Let's go to 9th question. 9th is what I did, right?
Yes, sir.
9th is what I did. So go for the 10th question. The 10th question is write down the expression for radii of the orbit of hydrogen atom. Radii of the orbit, appadina atom. It's not about nucleus. It's about the radii of the orbit of hydrogen. Means it's talking about not just the nucleus, it's talking about the electron revolving around. Okay, what is the radii of the smallest orbit? Okay, you know R from the lesson, this lesson, you know R is equal to R naught into n square, atoms lesson. R is equal to R naught into n square. That's what we are doing. Put, R naught is 0.53 Armstrong. Put n is equal to 1. That will be the radius of the first octet. So radius of any octet can thus be calculated using this formula. Why are they even doing all this? You don't need all this, because we have a shortcut where we have memorized R naught as 0.53 Armstrong. So let's go to next question. The 11th question. Calculate the velocity of the electron in Bohr's first orbit. So velocity is 1 by 137 into c by n, where n is equal to 1. You know that what is c, you can just substitute and get the velocity, provided this formula was derived with z is equal to 1, which only assumes for hydrogen. Is the question about hydrogen? Calculate the velocity of the electron in the Bohr's first octet of hydrogen, where n is already equal to 1, and just substitute this. You get 3 into 10 to the power 8 by 137, which should give you your velocity. For finding the velocity, take the 300 into 10 to the power 6 by 137. So that it's 2 137 into 2 is 7 2 14, 3 to 6 7, 274. So it's 2 point something into 10 to the power 6. So it's correct. So 2.2. So you don't have to do it in Aurora's way. It's very, very unnecessary. So 2.1 now, 2.18, it's okay. Okay, so you understand that why is Aurora doing in roundabout way? You don't have to do it like that. We have shortcuts for everything. We can use this formula provided it's a hydrogen atom. So let's go to 12th question. Determine the speed of the electron in n is equal to 3 of helium. Here you can't use it. Why? Because it's helium ion. Helium ion. Determine the speed of the electron in n is equal to 3. Okay, in this what I'll do, what is the basic difference in hydrogen? Z is equal to 1. In helium, Z is equal to 2. So I'll take the same formula, multiply it by 2. Everything else is going to be the same. Did we get this 1 by 137? Was there a mass in it? You should be careful. Okay, yeah. Can you see here? It's 2 pi alpha is 2 pi k e square by ch. There's no mass at all. So you don't have to really confuse. You just have to use the same formula. Correct? So therefore, when you know it's helium, you just take the same formula 1 by 137 into C by n and multiply it with a Z. That's all. Okay, so then on doing that, you will get the answer to be 1.46 into 10 to the power 6. For which octet n is equal to 3, is it? So substitute n as 3. This is 3 into 10 to the power 8. So just do the calculation, be done. 3 and 3 gets cancelled also. Okay, just do the calculation, get this answer. Let's go to 13th question. Show that the speed of the electron in the innermost orbit of the hydrogen atom is 1 by 37 the speed of light in vacuum. Is it similar to what we did?
Yes.
Okay, innermost, this is the innermost, n is equal to 1. So you have 1 by 137 into C by n, where n is equal to 1. Therefore, speed of the first octet is 1 by 137 into velocity of light. The same derivation. Show that. You know how to derive, you should know the formula for original formula, which is k is e square into 2 pi by nh, in which you have to multiply and divide by c, and then do the k is e square 2 pi by ch into c by n, and assume that n is equal to 1, and this z is equal to 1, and you get 1 by 137, and thus v is proportional to just speed of light. Are you clear? So let's go to next question. It's the 14th question. Calculate the period of revolution of an electron. Period of revolution means immediately you should write time period is equal to 2 pi r by velocity.
Yes.
Okay, calculate the period of revolution of an electron revolving in the first octet of the hydrogen. Given the radius r, even then if they don't give, they've given first octet. Radius of the first octet is 0.53 into 10 to the power minus 10. By velocity in the first octet is 1 by 137 into c. N is not there. So you just have to plug in this value, which will be c into 137. Correct?
Yes.
So this will give you your time period straight away. What is the time period? It's 1.52 into 10 to the power minus 16 seconds. Just do the calculation. Let's go to next question, 15th question. It's found experimentally that 13.6 electron volt energy is required to separate a hydrogen atom. Take a hydrogen atom. It consists of a nucleus in which there's proton. There's no neutron in hydrogen atom, no? Okay, so proton is there and an electron is there. To separate these two, it was found that 13.6 electron volt is needed.
Okay.
Compute the orbital radius and the velocity of the electron in the hydrogen atom. So since they have given this, you have to use this. Otherwise, orbital radius is nothing but r is equal to r naught into n square. Correct? N is equal to 1. 0.53. Velocity, v is 1 by 137 c by n is equal to 1. We can't use that. Why? Because it was something that is given. 13.6 electron volt of energy is required to separate. They've given something like this. Correct? So since they have given this energy, this is the total energy.
Okay.
And the total energy's formula is minus k z e square by 2r. And then can we plug in 13.6 here? And can we find r using this? Because rest of it is all constant. Since they've given total energy required, you have to plug in total energy. Use this. And it's in electron volt.
Okay.
So therefore you should multiply this with 1.6 into 10 to the power minus 19 is equal to minus 9 into 10 to the power 9 into z. What is z? Is it hydrogen atom? So z is equal to 1 and e square is 1.6 into 10 to the power minus 19 the whole square into 2 into r, and r is what you're going to find, cross multiply, get that. But we don't have to do all this. But since they have given the energy, I am forced to use this formula and the total energy formula. Next question they are asking, calculate the orbital radius, done, cross multiply and get it. And the velocity of the electron in the, to find the in the hydrogen atom, you can equate this to energy, right? Or no, you find the total energy here.
Yes.
You know the total energy itself is given. And do you know the total energy is negative of kinetic energy?
Yes.
So it's minus 13.6 into 10 to the electron volt. Minus 13.6 electron volt is the kinetic energy. Now from this I can equate it to half mv square and find the velocity.
Okay.
I can just equate this to half mv square and find the velocity. Total energy's value will be negative. Kinetic energy value will be positive. Total energy is negative of kinetic energy. Total energy is negative. Okay. And so then therefore this will be positive and equated and find the velocity v square. By taking the 2 that side, 13.6 into 1.6 into 10 to the power minus 19 into 2 by m, where m is the mass of the electron, which is 9.1 into 10 to the power minus 31. Just do this, you get v square and then find the square root, you get v. But why? We know it's 1 by 137 into c by n. But unfortunately, this sum we can't use that because you have to use the given point of 13.6 electron volt. Are you clear?
Yes.
So let's go to next question. This is example 16. According to the classical electromagnetic theory, calculate the initial frequency of the light emitted by the electron revolving around the photon. You know that the electron revolves around the proton. It's a subatomic particle, have wave nature, de Broglie will come. Yes. Remember? So then they're asking for the frequency. If you find the wavelength, you can find the frequency. Or you can find the time period. If you find the wavelength, mu is equal to c by lambda, hence you can find the frequency if you know the wavelength. Otherwise, you can also write 2 pi r by v, and if you reciprocal this, you get the frequency. Let's try both the methods and see. Okay. But do you know the wavelength? They didn't give you anything, correct? Yes, according to classical, calculate the initial frequency. So you have to use only, you know what is r and you know what is v. R is 0.53 Armstrong, radius of the first octet. Velocity is c by 137, correct?
Yes.
So then 2 pi r. Time period is 2 pi r by v. Frequency is therefore v by 2 pi r. Velocity is, we just now found that c by 137, correct?
Yes.
3 into 10 to the power 8 by 137 into 2 into 3.14 into r, which is 0.53 into 10 to the power minus 10. Let's take this and calculate and see if you're getting the same answer as them, okay? Was it 137? 1 by 137, you know?
Yes, ma'am.
Okay, yeah, but I'm not copying from him, I'm just doing it my way. Because this is the formula I know of, correct? So, okay, let's cancel off something. Nothing is getting cancelled. Okay, can we take this and this as the same?
Okay.
Approximately.
Okay.
So that becomes 1. So you're left with 137 into 0.5. Let's take it as 5. 5 5s are 25. 5 3 15, 17, 5 5 675. It's 67.5 approximately. So 1 by 67.5. Into this goes up, it becomes 10 to the power 18. So let's give it a 2. 100 by 67.5 into 10 to the power 16. This is, let's approximate it to 67 or whatever. Once 1 point, if it's it will be about 1.7 or something into 10 to the power 16. So see the answer.
But 2.2, not
No,
this
no,
one, sir.
6.6.
6.6.
Ayyo. Why is that I'm not getting an answer? Can you just explore? No, using my method. I did time period as 2 pi r by velocity. So frequency is velocity by 2 pi r. Velocity I took it as c by 137. 3 into 10 to the power 8 by 137 into 2 into 3.14 into r is 0.53 into 10 to the power minus 10. What has he done?
They have given 5.3 as
Oh,
the
they
radius.
no. Where have they given? They didn't give
no,
in the question.
In the question, they didn't give.
But that's nothing but 0.53 Armstrong.
Okay.
Whatever we took is only correct.
And is 2.2 into 10 power 6.
What are
meter
they?
per
What are they
second.
saying? They've mugged up the velocity,
Okay.
which means they seem to have
In meter
memorized
per
the
second.
velocity in meter per second.
Second.
Okay, let's do whatever I've calculated. V is equal to 1 by 137 into C by N. N is equal to 1, write as 3 into 10 to the power 8. Just calculate this 3 into 10 to the power 8 by 137. Give it a 300, it's 10 to the power 6 by 137. Okay, 137 into 2s are 7 2s are 14, 3 to 6 7, 2 1s are 2, 274. So 2 point something into 10 to the power 6. What are they given? 2.2, right?
Yes, ma'am.
Yeah, so it's the same. So let's muck up this. Just like how we have memorized r is equal to 0.53 Armstrong, velocity in the first octet of the hydrogen is 2.2 into 10 to the power 6 meter per second. So you write it 2.2 into 10 to the power 6 by 2 into denominator you have 3.14 into r you know 0.53 into 10 to the power minus 10, whose answer calculation mistake we have done 6.6 into 10 to the power 15 hertz. Just recalculate and see. We have not done any mistake.
Yeah.
Whatever we have done so far is correct only. But however, a new thing that you know is you can memorize the velocity of the first octet to be
Okay.
2.2 into 10 to the power 6 if you can. Okay. As the frequency of the electromagnetic wave emitted by the revolving electron is equal to the frequency of the revolution, so the initial frequency of the emitted light, we found the frequency, that will be the frequency of the emitted light also. It's a revolving electron's frequency will be equal to the emitted light's frequency. That's what it is. So let's go to next question. 17th question. A 10 kg satellite circles Earth once every 2 hours. So time period
Okay.
is 2 hours.
2 hours.
Okay, and it's revolving once every 2 hours. So time period for one revolution is 2 hours, and having a radius 8,000 kilometer. Assuming this is about a satellite, and the mass of the satellite is given to be 10 kg, is revolving around the Earth. So there is Earth here. The satellite is revolving around. The mass of the satellite is 10 kg, and taking 2 hours for time period, and the radius is 8,000 kilometers. Yes, I understood this. Seems like a gravitation lesson in 11th standard. Find the quantum number of the orbit of the satellite. Oh, n. Assuming that Bohr's angular momentum postulate applies to the satellite. So assuming that this is in some octet, find the n of this. You understand? But you know that n can come in only in Bohr's postulate, where L is equal to nh by 2 pi. But they're asking you to find the n. They didn't even give you the angular momentum. They didn't even give you the angular momentum. But you know that angular momentum, okay. Angular momentum is r times linear momentum.
Yes.
Okay, it's r is the radius which has been given, which is 8,000 into 10 to the power 3 kilometers. Into momentum is mass into velocity. Mass is 10 kg. Correct? Into velocity, linear velocity, you will have the time period with which let's find the velocity. Okay, if you you know the velocity is 2 pi r by capital T. Total distance by total time taken. So we can plug in this value here. So 8,000 into 10 to the power 3 into 10 into 2 into 3.14 into r, which is again 8,000, correct?
Yes.
By time period, which is 2 hours. Can we keep it in hours only?
Okay.
R is again 8,000 kilometers, right? We are converting that alone in meters. Why can't we keep that also in kilometers? Why can't we keep radius also in kilometers? Why can't we keep but when you substitute h, it will be in meter per second. You should be careful. Okay, you have to convert it into meter per second. Everything has to be converted. We don't have a choice. So we can't cancel the 10 to the power 3 and 10 to the power 3. Are you clear?
Okay.
So we can't calculate. Yeah, we have to keep it like this. And hours also should convert into second. Hours is 2 hours means into 60 into 60. Convert into seconds. You just calculate it. You'll get L. And n is equal is 2 pi L by h. Correct?
Yes.
So this 2 pi into this value into L by h, and you can calculate L. This is the way I am thinking of. What have they written in this question? They are calculating L, then MVR. Doesn't matter. We are also using MVR only. Can you see here we
Yes.
have. Just forget it. Conceptually, it's all the correct. We should get the same answer. Let's see if we're getting the same answer. Can we? So look at this. The 0, 0. Sorry. And this 0 get cancelled with. Let's cancel it with this 0. Huh? So what else you have here? Your calculation is a pain in the neck. You have a 10 to the power 3. Let's make it as 10 to the power 6.
Okay.
Let's consider this as 3 only.
Okay.
And let's approximate our answer. This is cancel this and make it 10 to the power 4. And cancel this and make it 10 to the power 5. And cancel this and make it 10 to the power 11. Correct?
Okay.
What are you left with? You're left with the 8 2s are 8 2s are 16. 8 8s is 64. 64 into 2 is 4 to 8, 128 into 3. 8 3s are 24, 3 2s are 6, 7, 8, 384. Correct?
Yes.
So 384 divided by 2 is there. 2 into 6 into 6 is there.
Yes.
We could have cancelled this. Anyway, we'll cancel now. This is 2 1s are 2, 9 2s are 18, 2 2s are 4. Correct? 6 3s are 18, 6 2s are 12. And this is 3 and this is 2 1s are 2, 6 2s are 12. 16 by 3. So you get as angular momentum to be 6. N is equal to 2 into 3.14 into L, which is 16 by 3 into 10 to the power 11 into 3. What is this? 6.6 into 10 to the power minus 34. And let's see what this will get you. Will it get you an answer? What is in here? What is the answer? N?
5.3
into 10 to the power 45. Appa. Yeah, we got a 45. We got a 10 to the power 45. This answer should get you 5.
Okay.
Is getting you 5. Let's see. 16 2s are 32. Let's 32 into 3. 32 into 3 is 3 to 6, 3, approximating 96 by 6.6 into 3 is 6 3s are 18, 19.8. So 19 5s are 9 5s are 45. Yeah, approximately 500. That is the number of octet. Are you clear?
Yes.
Superb. We can use our own way and do
Okay.
it like this. So you don't have to copy what is in Aurora. So next question is the total energy of the electron in the first excited state. What is the meaning of first excited state? N is equal to 2. What is the total energy of the electron in the first excited state of hydrogen atom is given to be energy E2 is minus 3.4 electron volt. Correct?
Yes.
We already know that, so that's the value. What is the kinetic energy of the electron in that state? Total energy is negative of kinetic energy, or kinetic energy is negative of total energy, therefore kinetic energy is plus 3.4 electron volt. Next, what are they asking? What is the potential energy? You know the potential energy is 2 times kinetic energy and negative of. Correct?
Yeah.
So negative of means double this is 6.8 with a negative minus 6.8 electron volt.
Yes.
Okay, next, which of the answers above would change if the choice of 0 of the potential energy is changed? Supposing the 0 of the potential, we consider all these values in the earth, the potential energy to be negative, considering the 0 is at infinity. Normally we consider 0 to be at infinity and we consider these values on the earth to be negative. If we are going to change the 0, it only depends on R. The position only depends on R. Kinetic energy will be unaffected.
Okay.
Kinetic energy has got no word called R. It only depends on half mv square, to be honest. So then therefore only the potential energy keeps changing and hence the total energy will change. The kinetic energy will never change.
Okay.
Due to the 0 of the potential change, the kinetic energy does not change, only potential energy, and hence the total energy changes. So let's go to next question. This is example 19. The ground state energy of the hydrogen atom, E ground state 1, is minus 13.6 electron volt.
Okay.
What is the kinetic energy of the electron in the second excited state? Kinetic energy of the electron in the second excited state, E2, is minus 13.6 by 4.
Second excited state means
Second
3.
excited state, n is equal to 3. So
Okay.
can I write it as 9?
9. Okay.
And just find the energy. That will give me my total energy. And kinetic energy is negative of total energy. Just remember that. Okay. So you get this answer to be, what is that? 9 means it's minus 1.51 electron volt. Therefore the kinetic energy is plus 1.51 electron
Okay.
volt. Next term. What is the potential energy of the electron in the third excited state? Third excited means n is equal to 4. What is the potential energy of the electron? You know, you find the total energy, which is minus 13.6 by 16.
0.85.
So that will give you minus 0.85 electron volt, which will give you kinetic energy to be positive at plus 0.85. And the potential energy is negative of 2 times kinetic energy. So double it and put a negative sign. So 5 2s are 10, 8 2 16, 17, 1.70 with a positive negative sign, 1 minus 1.70 electron volt. Correct?
Yes.
So let's go to next question. If the electron jumps to the ground state from third excited state, which means from n is equal to 4, it's jumping to n is equal to 1. Jumping from this, calculate the wavelength of the proton. You can use the formula 1 by lambda. Wave number mu bar is equal to 1 by lambda, which is, you can reciprocal it, right?
Okay.
Which is minus r into 1 by n I square minus 1 by n f square, correct?
Okay.
1 by, you know this value, 1.09 into 10 to the power 7 into initial is 4 and final is 1. So take LCM, minus of minus will become plus, correct? Wavelength cannot be negative. Beautifully it's
Okay.
becoming 15 by 16. Correct?
Okay.
So when you take 1 by lambda, what is lambda therefore? Is 16 by 15 into 1.09 into 10 to the power 7.
Okay.
This is approximately 1.
Okay.
சும்மா வச்சுக்கோயேன் 1 point என்ன வந்து இதுவும் 1.09 வருமோ 16 into divided by 15 ones are 15. The remainder is 1. Put a decimal.
Okay.
Still it's not going 0. And 15 nines, 15 6 are 90. So 1.06. What did I divide 16 and 15? 0.06, 1.09 10 to the power 7. This will take it as 1 year into 10 to the power minus 7. See if I have got the right answer. No, 970.
1.
No. We are finding wavelength.
No,
970. Why are we not getting the same answer? We have a problem in here, correct?
Yes.
No, I think we got it. You see, you want to make it into Armstrong.
Armstrong.
Which means you're multiplying with 10 to the power minus 3, therefore dividing by 10 to the power minus 3. Correct?
Yes.
So it will be 1000 into 10 to the power minus 10, which is 1000 Armstrong, which is approximately equal to 970.
Okay.
Because did we approximate anything here? We are doing it correctly only, no? Why are we not getting the exact answer? Using this formula, we should still get the same answer. You agree with me?
Yes, ma'am.
Just check 1.09 10 to the power
It's
7. He's not using my base, so just don't
Okay.
look at him. Just focus on what I'm doing. What makes this answer different? (16 by 15) is exactly what I did, which is 1.06. Maybe here I did 1, no? I have to actually divide 106 by 109. So when I divide, it will be 0 point, because not even 1 cell. 0.9 only will come, no? Correct, we got the answer.
Yes, ma'am.
So it will be, when you put another 0 here, it's 0.9, which is if you put, what am I doing? Divide 106 with 109. It is 0 point, you will do this. And then 109 into 9s are 9 9s are 81, 9 zeros are 0, 9 1s are 981. So the remainder will be 9 here and 5 15, so 7. This will become 979. So what did I get? 0.9. And if you want more, I can put one more 0 and say it's 109 into 7s are 9 7s are 63. Yeah.
Yes.
763. Yeah. 0.96. So this answer is 0.96 into 10 to the power minus 7.
Okay.
So you'll be closer. We in fact are getting a perfect answer than them.
6 valla 7
7 Varma, 7, 0.9. Correct.
Hmm.
So that's what it is. Okay, let's go to next. But I'm not doing Aurora's way.
Okay.
I'm just using this formula, which we already know. Yeah, we already have memorized it. So the calculation gets very, very easy in our way, correct?
Yes.
So let's go to 20th question. A monochromatic radiation of wavelength 975 Armstrong, which means 975 into 10 to the power minus 10 meters, excites the hydrogen atom. So this is about something which is going to excite the hydrogen atom. N is equal to 1 length, the electron is going to jump to a higher octet by the incident radiation. This wavelength is of the incident radiation which is coming and falling on it. So monochromatic wavelength 975 Armstrong excites a hydrogen atom from the ground state to a higher state. How many different spectral lines are possible in the resulting spectrum? Which transition corresponds to the longest wavelength? Okay, 1 second. Let's answer one by one.
Okay.
Let's find out to what excited state this can jump. This much energy is coming. This much wavelength gives you how much energy? E is equal to why can't I just do it like this? This is the incident energy wavelength, which is going to excite this to a higher state. So why that will be the why can't I use 1 by lambda is equal to 1.09 into 10 to the power 7 into 1 by n initial square by n by n final square. 1 by lambda is equal to minus 1.09 10 to the power 7 into 1 by n initial is 1 square. It's jumping from here to the final of unknown square. Correct?
Yeah.
And you know lambda itself is 975 Armstrong. Can I plug in 975 into 10 to the power minus 10?
Okay.
So if I do that, let's see. This is going to come down.
Okay.
So it will be 1 by 975 into 10 to the power minus 10 into 1.09 into 10 to the power 7. This negative sign can go in, correct?
That's
and I'll get 1 by n square minus 1. I can bring the 1 that side. So I can multiply these two. And this will become 10 to the power minus 3 and 9.75 into 1.09.
Okay.
Let's make it as 9.75 as 9.8 and let's make this as 1.1. 9.8 and 1.1. Okay, 11 8s are 88, 11 9s are 99. 99 plus 8, 107, 10.78. So you have a 10.78 into 10 to the power minus 3. When this goes up, it's 10 to the power 3 by 10.78. Can I approximate this to 1000 by say 10 for now?
Okay.
For now. So I get this one to that side. 1 by n square. I wish it was 107. Let's consider this as 11.
Okay.
So a 10 divided by 11. What is it? 1000 divided by 11.
Okay.
11 9s are 99. 10. And so then it's not going. So can I? 11 9s are 99. So is it 9.9?
Yes.
This itself is 9.9 into 10 to the power. No, the 10 to the power 3 I've already taken out. So it's just 9.9, correct?
Yes.
And I'm bringing the 1 to the other side. Correct?
Yes.
So this will become, say, 10.9
9
is equal to 1 by n square. N square is equal to 1 by 10.9. Yeah, so then what is 1 by 10.9? Let's consider it as 1 by 11.
Okay.
And 1 divided by 11 is 0.1 more 0.
9.
9s are 99. So enough. So this is 0.09 is n square, and n is equal to root of 0.09. 0.3 into 0.3 is 0.09. So answer is 0.3. How can you have an n to be 0.3? It's some shit. Correct?
Yes, ma'am.
Yo.
Like getting a 6 or something.
Okay, so let's find out our mistake. We'll not look at what he has done. So what I did, okay, let's see what is the mistake. It's important to understand our mistake. This is the incident energy. This is the incident radiation, which is going to excite this from here to here, which means this energy gap is caused by this wavelength.
Okay.
So if some electron falls from here to here also, it will emit the same wavelength.
Okay.
So under that concept, I took it like this, and I wrote 1.09 10 to the power 7, 1 by n initial square, 1 by 975 Armstrong. I think here one mistake I did. I'm considering the converse of the situation. Here it's the incident radiation, correct?
Yes, ma'am.
Which means in incident radiation is jumping from here, it's jumping here.
Okay.
But when I use this formula, I'm talking about emitted radiation.
Emitted, yes.
In the emitted radiation, then I'll do this is n and this is, it is going to jump from there to here.
Yeah.
So that will be unknown minus final is 1.
1.
This is the converse situation.
Okay.
So the n square will come here and 1 will go there.
Okay.
So then when I take the LCM minus sign inside, it will become a 1 minus, this I brought it down. I have a 1 by n square minus 1,
Okay.
which is going to be juggled now. It will be 1 minus 1 by n square. 1 minus
1 by n square.
1 by n square. If you take the 1 by n square to the other side, I get 1 minus 1 by 9. This answer we calculated, right? It's 9.9, right?
Yes, ma'am. We got 10.7.
Yeah, we divided by 1000, remember,
Yeah,
and we
yes.
got it as 9.9. So we know that this is 9.9. What is 1 minus 9.9? Why are you getting negative answer? Are you sure we got 9.9?
Minus 13.6. That formula we can use.
Okay, yeah, we are changing the formula.
Okay.
You are looking at that and telling me,
Yes.
yeah, but I proceeded like this. I should get the answer in this method.
Okay.
See, you can't say this method won't get you answer, that method. Everything is physics.
Yes, ma'am.
Okay, I'll come back to this method again. I'm not quite convinced. I should get an answer in this method itself.
Okay.
I don't agree the fact that I'm not getting an answer in this method, but however, the alternative method that I can do is the incident wavelength is given, I find energy. E is equal to h mu, E is equal to h into c by lambda. H into c we have memorized. What is h into c? From that lesson, 1.9 into 10 to the power minus 25 by wavelength is 975 into 10 to the power minus 10. This will be the incident energy.
Yes.
You want in electron volt, all the more easier. You want in electron volt divided by E. And write hc by E to be 1.2 into 10 to the power minus 6 by 975 into 10 to the power minus 10. Getting this energy answer is in electron volt.
Okay.
Once you get this energy, what you do is there's a minus 13.6 electron volt here.
Yes, ma'am.
Add this energy to this value to this.
Okay.
So the total energy now changes.
Changes.
What is this energy's value? So it is take it up. It will be 10 to the power 4 and multiply it inside. 1 0 goes there and you get 3 zeros, is it? And just see and tell me. 10 to the power 4 means 1, 2, 3, 4. Correct?
Yes.
By 975. So then you can divide and find the answer for this. Assuming it's 1000. It's 12 electron volt, right?
Okay.
Assuming it's 1000. Okay. So the total energy now is 12.
Okay.
So substitute in En is equal to minus 13.6 by n square. Substitute the 12 here.
Okay.
So n square is equal to minus 13.6 by 12.
Okay.
So it's minus 12 ones are 12. 16, 12, 1.1. A square root of 1.1. What is the after they are saying n is equal to? 6, huh?
N is to find. N is equal to 6.
Let's see what's a mistake. Okay. They're finding the energy to be 12.7. Yeah, that's
Yeah, we
correct.
got it.
We got it. Okay. Now they're adding it to the minus 13.6.
Hmm.
So we also did that. Oh, I didn't add. Did I add minus 13.6
No.
and 12.7? Yeah, I did. And became 16, and this became 3 here and 6, 9. 0.9.
Yeah, 0.9.
Okay, so that's minus 0.9 electron volt is the total energy.
Okay.
So in this, in this total energy, I should write 0.9 is equal to minus 13.6 by n square. So n square is minus 13.6 by 0.9.
Okay.
So it's 136 by 9. 9 ones are 9. 9 means 10, 11, 12, 13, 46. 9 5s are 45. N square is 15. N is equal to square root of 15. Square root of 15. 3 3s are 9. 4 4s are 16. So it's between 3 and 4. I'm not getting 16. I'm supposed to get 6. Just see total energy.
0.9 is correct.
So it's 15 also is correct. N
Yes.
square is 15. N
They
is
are
equal to 4.
approximate.
Correct.
Yes, they are
N is equal
approximate.
yeah, 4 4 6.
Okay.
N is equal to 4. It can't be decimal number. So you're taking N is equal to 4. That is fine.
Okay.
So we could answer. This method is so much more easier. So whenever they give you incident wavelength, you calculate the energy using that incident wavelength.
Okay.
And that energy will be positive added to minus 13.6.
Okay.
Which means you're subtracting basically.
Yes.
You get the new energy and substitute in En is equal to. So this method, let's not use this method that I used.
Okay.
Whenever you have incident wavelength, we'll never use this formula. We'll use this only. Okay, so then you got N 4.
நீங்கள் 1970 நம்ம இது பண்ணிட்டீங்க.
Sorry, N is equal to whatever. Okay, N is equal to 4 or how many jumps are possible? N into N minus 1 by 2.
Okay.
So 4 into 3 by 2, totally 6 jumps are possible. When
Okay.
jumps is 6. Okay, were they given 6?
Yes, ma'am.
Number of spectral line emitted is 6.
Okay.
How many jumps? That many spectral lines will be emitted. You know, N is equal to 4 means, look at this. This 4. This is 3. This is 2. This is 1. Jump from 4, it can jump to 3.
Okay.
From 3 lane it could have jumped to 2. From 2 lane it could have jumped to 1. And from 4 lane it could have directly jumped to 3. 4 lane it could have, then it could have jumped here, which is already written. It could have jumped here. 4 lane directly. And then 4 lane it could have also jumped to, how much is there? 1, 2, 3, 4, 5. We need one more. 3 lane it could have jumped direct.
Okay.
So then that many jumps, the formula is n into n minus 1 by 2. Are you clear? Very, very important sum. I messed up in the beginning.
Okay.
Whenever they give you incident wavelength, calculate the incident energy, add it to minus 13.6. It will be basically subtraction. Then you substitute in total energy is equal to minus 13.6 by n square. You substitute total energy and find n. That's the best way. Okay, let's go to next question. Example 21. The energy level diagram of an element has been given here.
Okay.
Identify by doing necessary calculation which transition corresponds to emission of spectral length. Oh, then there's one more question, okay. The previous question has got one more subdivision. Which will have longest wavelength? I'll tell you, the wavelength has to be longest. The frequency has to be shortest. If the frequency has to be shortest, the energy has to be least. Which means it's jump from immediate above orbital. So which of these jumps has got minimum energy gap? 4 to 3. Because as you go up, the energy gap is less, no?
Yes.
Correct? So 4 to 3, have they written that in the previous question?
Yes.
N is equal to 4.
N equal.
Are you clear?
Yes.
So in this you have to identify which will have the greatest wavelength, the one which will have the least frequency, which will have the least energy gap. So identify. Are you clear?
Yes.
So let's go to 21st question. 21st question, the energy level diagram of an element is given. Identify by doing necessary calculation which transition corresponds to emission of spectral length. See, emission, the wavelength emitted, not incident wavelength. Okay, the wavelength emitted is 102.7 nanometer. Okay, the best thing is whenever they give you wavelength, you find E is equal to h mu, mu is equal to C by lambda, convert into electron volt, because you know hc by E is 1.2 into 10 to the power minus 6 by 102.7 nanometer 10 to the power minus 9. By calculating this energy, you'll get the answer in electron volt.
Okay.
You can compare it with the difference. You just subtract A. That is subtract minus 1.5 minus of minus 0.85. It will become plus 0. Eventually it will get subtracted.
Okay.
You calculate this energy. Second case, you calculate this is A's energy. What is A's energy? 1.5, 0.85. So this will become 5, this will become 4, and this will become 6, and this will become 0.65. Correct? So this becomes 0.65 electron volt. The advantage is the incident energy also you have in electron volt. You have to calculate this. How to calculate this? The calculation only is you can take 1.2 into 10 to the power 3 it becomes. By 102.7 it becomes.
Okay.
You can as usual take it inside. So you'll get 1, 2, this 3 only. So 1 0 goes, another 2 zeros only has to come. By 102.7. You can multiply both the numerator and denominator by 10. You get it like this.
Okay.
So you let's do this is like take it like 1000.
Okay.
Approximate this to 1000. So it will be 12 electron volt. Correct?
Yes.
Compare this 12 electron volt with the gaps here. This is so small. This is so big. Next for B. What is it for B? It's what is the energy here? B's energy. Come on, tell me.
B is
Minus 3.4 minus. Where is it falling from?
Falling from
B. So look at the diagram. B is falling to this from
minus 0.
minus 0.85. So it will become minus 3.4 plus 0.85. So minus 3.4 plus 0.85. Put a 0. This will become 5. This will become 13. This will become 2. This will become 5 and 2.55. So thus you get minus 2.55 to be the energy of this. You can compare it with the 12 electron volt also. C. What is C?
C is
Falling from
3.4.
minus 3.4 minus of minus 1.5 minus 3.4 plus 1.5. 3.4 or 1.5 subtract panna, this will become 14. This will become 9. 1.9 minus 1.9. Let's go to D. What is D? It's falling from minus 13.6 minus of minus 1.5. So minus 13.6 plus 1.5. 13.6 and a 1.5 when subtracted becomes minus 12.1.
Okay.
It's approximately equal to this. Correct?
Okay.
So what is the question? The energy level diagram of the element is given. Identify by doing necessary calculation which transition corresponds to. So this transition will give you this much energy.
Okay.
Which is from D. The answer is therefore D.
D.
Are you clear?
Yes, ma'am.
You must not miss 1 mark also in all this. Okay, I'm doing each and every sum in this. So let's go to example 22. The energy of the electron in the hydrogen atom is given to be minus. So whenever they give you wavelength, always prefer to Hc by E into divided by lambda.
Okay.
That Hc by E is 1.2 10 to the power minus 6. Calculation becomes
Easy.
very easy. So electron volt answer kadichirutte. So let's stick to that. I messed up in one sum. Don't do that method. Whenever wavelength is there, we'll follow this method. So energy of the electron in the hydrogen atom. Electron in the hydrogen atom cannot have an energy minus 6.8. The electron in the hydrogen atom cannot have an energy minus 6.8. Why? So you write minus 6.8 is equal to minus 13.6 by n square. N square is equal to 13.6 by 6.8.
Okay.
It will become root 2 and all. Octet cannot be, it can be only 1, 2 or 3. It cannot be root 2 and stuff, correct?
Yes.
This is approximately say 2. N is equal to root 2. If octet cannot be 1.414, right? Is that what you are saying? Electron in hydrogen atom. So these are the energy value. Can you see?
Yes, ma'am.
When you substitute, you get the respective energy values as given here. So clearly the electron in the hydrogen atom cannot have an energy minus 6.8. Whereas I am doing like this.
Okay. Just doing the
Calculation arriving at 1.4, which is not possible, but this is a better because there and all also we have rounded it off 15.1.
Okay.
We still wrote no, so do it like this only. Whatever they have done in Aurora is a better way of doing. So let's go to next. Clearly, an electron in hydrogen atom cannot have an energy minus 6.8 electron volt. As the next question, spacing between the lines, that is consecutive energy level, within the given set of observed hydrogen spectrum decreases or as n increases. The spacing keeps on decreasing. You know, energy level diagram, it keeps on decreasing. That's all. So let's go to next question. Is example 23. So example 23 seems to be similar to 21, right? Have they given the wavelength? Yes. Whenever they give you the wavelength, immediately calculate hc by E by lambda. hc by E is 1.2 into 10 to the power minus 6 by 496 into 10 to the power minus 9. You get the answer in electron volt, that's the incident energy. Then you subtract all these energies, see corresponding which will have emitted. Find out the transmission which would have emitted the radiation. So you know how to do that.
Yes.
Next, which transition corresponds to the emission of radiation? Maximum wavelength. Maximum wavelength means minimum frequency. Minimum frequency means gap has to be least, and that occurs when 4 to 3.
Yes.
Why are they saying 4 to 3? Yeah, correct. Are you clear?
Yes.
So it's the easiest way in which I've taught you.
Yes, sir.
Okay, so let's go to next question. Using Rydberg formula, calculate the wavelength of the 4 spectral lines in Lyman series. So this they specified R into 1 by Ni square minus Nf square because negative sign we used to put.
Okay.
Okay, so then they are writing Lyman series.
Okay.
So from this they are finding what is this 1 by lambda, right? They are reciprocal and written a formula for lambda. You can even keep it like that. Then they are arriving at a new formula, and then they are substituting 2 to 1. You can also do it here. Jumping from 2 to 1, 3 to 1, 4 to 1. Instead of Ni square, you can keep substituting.
1, 2.
Yeah, which means jumping from higher octet to lower octet. Just do it normally. You don't have to follow this method, but you can do it normally and get all the respective wavelength. This is easy, useful to find wavelength directly.
Okay.
But wavelength is given, always convert it to energy in electron volt and then do the sum. Are you clear?
Yes.
So next is using Rydberg formula, calculate the wavelength. Means we'll use this formula only.
Okay.
And I won't use this formula because I'll use minus R into 1 by Ni square minus Nf square. You know me. Okay. So, but they've given N1 is 2, N2 is 3, 4 and 5 and so on. Just do all the calculation, get the values of the different wavelength. Correct?
Yes.
So calculate the shortest wavelength. A shortest wavelength means highest frequency.
Yeah.
Highest frequency means energy gap should be maximum, which means you should fall from infinity to which Lyman series? N is equal to 1.
Okay.
From infinity to 1
1.
will give you the
Okay.
highest frequency, which is the shortest wavelength. Have they done infinity to 1?
Yes.
And they are finding the wavelength. So you can use 1 by lambda is equal to minus R into 1 by Ni square minus N by Nf square. So next is calculate the shortest wavelength. Again highest frequency. Which means infinity to Balmer series. N is equal to 2. Infinity to 2.
Okay.
Then you get the value of the wavelength. Are you clear?
Yes, ma'am.
Next is using
It works.
Rydberg formula. Again the same way.
Same thing. From
Lyman series and Balmer series, longest wavelength. Longest wavelength means shortest frequency. Shortest frequency of Lyman series is 2 to 1.
Okay.
Shortest frequency of Balmer series is 3 to 2.
3 to 2. Yes.
Just get the substitute those values and get the wavelength. Can I go to next? So I'm just discussing the questions. I'm not doing the sums in video, but I'm discussing H alpha line. What is the meaning of H alpha line? H alpha line and H beta line are those which belongs to Balmer series.
Yes.
Visible region. In visible region, we get to see further spectral lines splitting up, which is called H alpha and H beta line. H alpha is when it jumps to from 3 to 2.
Okay.
It's called H alpha. From 4 to 2, it's called H beta.
Beta.
They ask you H alpha line, H beta line. You should know it belongs to Balmer series. So it has to jump to N is equal to 2 from either 3 to 2 or 4 to 2. That's what is H alpha and H beta. Next term. So these are enough. You don't have to do more.
Yes.
With these that you have done, you should be able to do every sum which is marked CBSC further. Okay? I'm stopping the recording.
Okay.